So part C says I have a graph here of the velocity, and part C asks when is the acceleration negative, when is it positive, and when is it 0? And so we remember from yesterday, that the acceleration is going to be the derivative of the velocity. So if they give me a velocity graph and I want to know something about the acceleration, I'm looking at the slope. So here we go. V prime equals the acceleration. And I want to know when this is negative. So look at the slope. So when does my velocity graph have a negative slope? Okay, 2 to 3. Any others? 5 to 6. And then it also asks when V prime is positive. So I'm looking at when the velocity has a positive slope, which is 0 to 1. Any others? No. And then they ask when the acceleration is 0. And so it's got to have a slope of 0. So it's going to be a straight horizontal line. And that occurs from 1 to 2, and then 3 to 5. Okay, so the next question asks about speed. And so we need to define speed first. Speed is the absolute value of the velocity. And that makes sense if you think about it. We don't talk about, hey, I was driving negative 30 miles per hour or negative 150 miles per hour in my calculus Ferrari, right? Speed is always positive. So I'm going to look at my velocity graph and find when it has the greatest value, either positive or negative. So there it's 2, and there it's like negative 2. The greatest value, absolute value, would be right here at negative 4. So its greatest speed is going to be when t is equal to 6. Distance from the x-axis. That makes sense? Correct. All right. Yes.
What if you're doing an acceleration?
And you're asked about the speed. I would not give that to you right now. I would not ask you that question right now. Maybe later. Okay.
So that's 6.
But the greatest speed is at 6. Yes. All right. Gonna break on through to the other side. Here we go. Next page. A particle moves along a line so that its position at any time for t greater than or equal to 0 is given by the function s of t is equal to t squared minus 4t plus 3, where s is measured in meters and t is measured in seconds. Okay, so I have 2 graphs here. Which one is my position? The one on the left, because it's my parabola. So I've got t squared minus 4t plus 3. And the one on the right is the what? It's going to be my velocity. How do we know it's the velocity? How do we know it's the derivative? The degree is 1 less than the position function. And so my velocity equation would be 2t minus 4. And part A says, describe the motion of the particle. At what values of t does the particle change directions? Okay, so we can look at the graph and tell when it changes direction. We saw this yesterday also. How do we know when the particle changes direction? When what goes from negative to positive? So for example, this goes from negative to positive right here. Does it change direction?
No.
No. It changes direction when the velocity is equal to 0 and there is a sign change. Okay, the particle changes direction when v equals 0 and changes signs. So I can look at the velocity graph and see that it's going to change direction once right here. Oh. And if I set my velocity equation equal to 0, I have 2t minus 4 equals 0. Therefore, I move the 4 over and divide by 2. So t is equal to 2. It's going to change directions after 2 seconds. At 2 seconds. And so when we describe the motion of the particle, you need to do it like this. Tell me where it starts. Tell me where it changes direction. And tell me which direction it is moving during those times, okay? So let's find the initial position of the particle. So I'm gonna plug 0 into my position equation. And when I do that, you should get 3. So the particle is going to start at 3. And then does it move to the left or to the right? And how do you know? How do you know? How do you know? Oh, but what shows direction? Position or velocity?
Position. Velocity. Position.
Velocity shift.
Well, on the moving graph, when it goes to the right, it moves forward or
It's moving to the left.
left.
Okay.
Okay, if you turn the graph sideways, it'll show you which direction it goes. That's how I learned it.
Which does
Hold
that
on.
make sense?
Hold on. Let me explain. Look at the velocity equation, which is this one. Well, first of all, let me show you why it's moving to the left. What time does it change directions?
2.
At 2. Where is it at? At 2 seconds.
What?
Take 2 and plug 2 into the position. And you get -1. So it starts at 3. And then after 2 seconds, it's at -1. So it is moving to the left. Here's why it's moving to the left, okay? If I have the velocity equation, here's 0, here's 2. Is my velocity positive or negative? It is below the x-axis on the velocity graph. Therefore, it is moving left. If I have the position equation, I'm looking at the slope. What is my slope from 0 to 2? Positive or negative? Negative. Therefore, it is moving left.
So when you were asking the question earlier, the initial, like, since it does change direction, it goes back from left to right.
That's true. So like if I plug in 3, what is S of 3? If you plug it in, you get 9 minus 12 plus 3, which is 0. Okay, and so now that I have this information, let me describe the motion of the particle. Okay, the particle starts at position S is equal to 3. And moves left for 2 seconds to position S equals -1, and then moves right. It only changes direction one time because my velocity graph is only 0 and changes signs once, right here at 2.
Where'd you get the, like, what equation did you plug in to get the 3, like the initial point?
This
No, like S0 equals 3. Which one did you plug it into?
This is S of 0. So I plugged 0 into the position equation. So I've got 0, 0 plus 3.
Okay.
That makes sense?
Yeah.
Okay, part B says find the displacement of the particle during the first 2 seconds. So displacement is your position relative to your starting position. It's where you are relative to where you began. So I know that I began at 3 because that is my initial position. And they want to know the displacement at 2 seconds, and I already found S of 2. S of 2 is equal to -1. Therefore, I'm going to do S of 2 minus S of 0. That's going to give me -1 minus 3. So my displacement after 2 seconds is -4, which means I am 4 units to the left of where I started. So let me write that down. The particle is 4 units to the left of its starting position.
You have to say negative if you're saying it's going to the left. Oh, wait, you didn't say.
No, you can tell me it's 4 units to the left. It's -4. I think any of those would be fine. Okay. Questions so far? Anything you want to clarify?
Wait, why do you subtract S of 0 right there? Or S of 2 minus S of 0?
That's how you find the displacement, okay? It's the difference between where you began and where you, whatever time they ask you for. There. Okay,
So fast for like T or S of 1 seconds.
you would do S of 1 minus S of 0. All right, well, on the next one, this one can be tricky. At least it seems that way for students. They tend to miss this problem, okay? Part C says, find the average velocity of the particle during the first 4 seconds. Okay, so look at me for a second. What are we finding?
Acceleration.
We are not. We're finding a what? Of what?
Velocity.
We're finding a velocity. a velocity, okay? So if we're finding a velocity, my answer has to be in terms of, think about the units. It helps me to think about the units. It has to be meters per second. So how do I get meters per second? Well, my numerator is going to be the change in the position. My denominator has to be change in time. So if they ask me for the average velocity, this has to be over the first 4 seconds. This would have to be S of 4 minus S of 0 over 4 minus 0. And so to get S of 4, I'm going to take 4 and plug it into the position equation. So let's see, I got 16 minus 16 plus 3. So that's going to be 3. S of 0 was also 3. So I got 3 minus 3 over 4, which is going to give me 0. And let's put the units on there. This is a velocity, right? My position is meters. My time is seconds. So my average velocity over the first 4 seconds is 0 meters per second, which is a little, I guess, strange to think about at first glance, but all that's saying is that it has positive velocity and it has negative velocity, and those are balancing each other out over the first 4 seconds, right? But if I'm finding average velocity, it's the change in the distance over the change in time. Okay? You need to remember that. And part D says find the instantaneous velocity. And when you see that, I think to myself,
Derivative.
what a wonderful world. No, I do think to myself, this is the first derivative. So I need to take the derivative of the position, which I did. It was 2t minus 4. And so they want the instantaneous velocity when t is equal to 4. So I need to find v of 4. And plugging 4 in, that's going to give me 8 minus 4, which is 4. And that is meters per second. And the second part of this question says, and the acceleration when t is equal to 4. And so now I need to get my acceleration equation. Acceleration, that's going to be second derivative of the position, or the derivative of the velocity. So a of t is the derivative of 2t minus 4, which is 2. Meaning that I have what? I have a constant acceleration. So acceleration is constant over time. We already knew this, however, right? How did we know this? Well, look at the slope of this graph. When is it 2? Always.
0.
It's at 0, it's at 3, it's always 2, okay? So the acceleration is constant over time. And part E says, on the interval from 0 to 2, is the particle speeding up or slowing down, and why? Well, we looked at this yesterday. How do we tell if the particle is speeding up or slowing down? The acceleration and the velocity have to have the same sign for it to be speeding up. And if they have opposite signs,
Slowing
it
down.
is slowing down. So let's look at the velocity graph. From 0 to 2, the function is below the x-axis on the velocity graph. Therefore, the velocity is negative. However, the slope is positive. So my acceleration is positive, they have opposite signs. Therefore, it is slowing down. So I'm going to write it like this. The particle is slowing down. Now I got to get the justification point. Particle is slowing down because the velocity is negative. From 0 to 2. And the acceleration is positive from 0 to 2. All right, I think it's time for a little calculus stretch break. So let's go, stand up. Why don't you look at an art project or something around the room? Do what? That one below the dots, I believe. If I remember correctly. I'm pretty sure that's it. Hurry, please. All right, you do need a calculator for this one. So here we go. A ball is projected into the air and it reaches a height of S of t is equal to negative 16t squared plus 30t plus 75 feet after t seconds. Okay, so in this example, the position of the ball, what does the position give me? Gives me the height. In terms of the projectile, S equals negative 16t squared plus 30t plus 75. What does ds dt represent? What is this? You have not seen this notation yet. You will. We will use it later. But what is ds dt? When in doubt, it's the
Derivative.
the derivative, but the derivative with respect to, what is the dt? With respect to time. My time is on the x-axis. So this says, name 2 ways you can find the maximum height for this problem. So let's think about this for just a second. I have a graph. The maximum height is going to be somewhere right here. What is my, this is the position function again. What is my velocity right here? How do we know it's 0? There's a horizontal tangent there. So if I wanted to find the maximum height, I could set v equal to 0 and find the time. And plug in the time. And my position equation S of t. So let's do that. I'm going to answer part A here. It says, what is the maximum height? I'm going to take my velocity equation. And so the velocity equation is going to be the derivative of the position. So that's going to give me negative 32t plus 30. And if I take this equation and set it equal to 0, now I'm going to solve for t. That will give me the time when it's at its maximum height. So let's see. I'm going to move the negative 32 over. So that's going to give me 30 equals 32t. And then I'm going to divide by 32. So t equals 30 over 32, or 15 over 16, which is, as a decimal, that would be 0.9375. So now that gives me the time when it's at its maximum height. And in order to find the maximum height, I need to take that time and plug it back into the position equation. So I want to find S of 0.9375. So take your little calculator, put in the position equation, and find S of 0.9375. And can somebody help me out? What'd you get? I got 89.063, and that's measured in feet. It's measured in feet. Okay, well, that's one way, but wait. It says name two ways. I'm a little disappointed we didn't come up with the slacker way. What's the slacker way?
Put it in your calculator.
Right on, my friend. All right. Put it in my calculator and do what?
On the max.
Find the vertex. Find the vertex using max feature there. Okay. Now we're going to do a little quick hits here. Part B. At what time does velocity equal 15 feet per second? So what I need to do here is take my velocity equation, negative 32t plus 30, and set it equal to 15. And I want to find the time. So let's see, I'm going to subtract 30. That's going to give me negative 32t equals negative 15. And then I need to divide by negative 32 on both sides. So t is going to be 15 over 32. Or as a decimal, let's see, that's like 0.469 seconds. Part C. What is the velocity at 2.5 seconds? So I want to find v of 2.5. And so I'm going to plug 2.5 into my velocity equation. Negative 32 times 2.5 plus 30. Negative 50. What are my units? Negative 50. What? Feet per second? Does it make sense that it's negative? What does it mean that it's negative? It means that the ball is dropping at 2.5 seconds, right? And yes, look at the graph there, it's going down. How long is the ball in the air? How would we work this problem? Okay, so you're saying that right here, it hits the ground. And I want to find that point. How would we do this? Use your calculator. So I would take the equation of the position and find the 0 on the calculator. So do that for me, please. And I am going to be on pins and needles waiting for your answer.
Hold on.
T equals 3.297 seconds. I'll put myself a little note here. Use 0 key on the calculator. And part E says, what is the velocity the instant the ball hits the ground? So it hits the ground at 3.297 seconds. And I want to know the velocity. So I'm going to find the velocity at 3.297. And so let's see, that's going to give me negative 32 times 3.297 plus 30. And put that into your calculator and crank out that answer. And it's got to be negative again, right? Because it is dropping. Someone have it? I got negative 75.504. And that's going to be feet per second again.
I wish I knew how to do this in physics last year.
And part F, what is the average velocity on the time interval? And I put a little warning there, be careful. How do we find average velocity again? Can we do it without looking back? It's going to be the change in position divided by change in time. Okay, so in this case, if I want the average velocity over the interval from 0 to 2, I need S of 2 minus S of 0 over 2 minus 0. Think about the units again. I need feet in my numerator and seconds in my denominator because I need a velocity. It's an average velocity. And so I need S of 2. So take 2 and plug it into the position equation. Check that. I got 71. Plug it into the position. And then if you plug 0 into the position, it's just going to leave the constant there, which is 75. And I got a 2 in the denominator, so that's going to give me negative 4 divided by 2, which is negative 2 feet per second. All right, any questions over any of those there?
I didn't get D, like without the calculator, since I didn't have like what was the process for D?
D.
Sorry. You need to graph the equation, okay? So I'm going to graph the position equation, this right here. And then on the graph, go to the trace, and I'm going to calculate the 0 there. And I can show you in just a second how to do that on the calculator if you want.
Can you do without one?
You can. You would have to either factor it or use the quadratic formula, which would be complicated in this case.
Yeah.
I could give you something that factored fairly easily though.
Okay.
So, yes. All right. Well, now it is time, my dear students, to head on into the calculus jungle. You know what that is? Put away those calculators. Welcome to the jungle. We do have fun and games. I mean, I just have a philosophical question. Was there any math done before the invention of the TI calculator? I don't know. I mean, Newhouse probably didn't even study math in high school because we didn't have TI 84 calculators, right? I mean, I don't know. Maybe we should ponder that for a second. Okay, time to go into the jungle. Here we go. If the position in meters of the body at time t in seconds is S of t is equal to t cubed minus 4t squared minus 8, find the object's acceleration each time the velocity is 0. Okay, so two parts to this question. First, I need to find when the velocity is equal to 0. They give me the position, and so to get the velocity, I'm going to take the derivative. So v of t is 3t squared minus 8t. And they asked me to find when the velocity was equal to 0, so I'm going to set this equal to 0. Now what? I'm going to factor a t out, and that's going to give me 3t minus 8 is equal to 0. So now I know that there are two times when t is equal to 0. The first one is
0.
0. The second one is at 8/3. That's the first part of the question. The second part says to find the object's acceleration at each of those times. Okay, so now I need A of t, and A of t is going to be the derivative of the velocity. So 6t minus 8 is my acceleration equation. And now I'm going to find A of 0. And so that's going to give me -8. And my units would be meters per second squared this time. And finally, I need A of 8/3. Oh no, a fraction. Let's see. 6 times 8/3 minus 8. 6 times 8 is
32.
48.
48.
Calculator, where have you gone? 48 divided by 3 is 16. 16 minus 8 is 8 meters per second squared. And there we go.
How do you get 8/3 on the 10?